Good morning. Myself Prabha Arunje, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to talk about the topic name is clock strategy from the unit 3 of sequential logic circuit in VLSI design. Let me discuss. Okay. Clock strategies refers to the techniques used to distribute and manage the clock signal in digital systems, particularly in synchronous designs where components are coordinated by a clock signal. In clocked system, the clock plays a crucial role in controlling the timing of operations across the entire circuit. Here we have discussed some of the points. First one is single phase clocking. In single phase clocking, there is only one clock signal that is distributed throughout the system. The rising edge or falling edge of the clock signal is used to trigger all sequential elements such as flip-flop and or latches. Some of the advantages is simple design, easy to implement and control. And the this single phase clocking has some disadvantages like time issues, like clock skew can become significant in large designs, high potential for timing related errors, especially in systems with long propagation delay. And next one is two-phase clocking. Two-phase clocking uses two non-overlapping clock signal. The clocks are designed so that when one clock is high, then other clock is low, and vice versa. This method allow more precise timing control. And advantages of two-phase clocking is reduces the effect of clock skew since the two clocks are distributed differently, allows for better control of the timing of various components. And it has some disadvantages it requires a careful design to ensure that the two clocks don't overlap. More complex circuitry due to need of generating and distributing two clock signals. And next one is multi-phase clocking. Multi-phase clocking extend the two-phase strategy by using multiple clock signals that are out of phase with each other. This is commonly used in pipeline architecture where different stages of pipeline operate on different clock phases. Advantages of this multi-phase clocking is can it can support higher throughput is pipeline system, help reduce timing issues in complex systems. And some of the disadvantages is more complex to design a circuit, more difficult to manage clock skew and timing issues. And next one is clock gating. Already we have discussed this clock gating. Asynchronous clocking means different part of the system operate on different unsynchronized clock. And also its disadvantages and advantages already we have discussed. And clock distribution network, the strategy of distributing the clock signal throughout a system crucial, avoid clock skew. Clock skew, this is a common method, include HV free distribution, misclocking, global or local buffer. Next one is skew compensation to counteract clock skew techniques such as clock deskewing circuit or delay insertion can be used. This strategy ensure that all part of the system receive the clock signal within a acceptable timing limit. And clock strategies in latches and registers. Let me discuss. Latches typically use level sensitive clocking and may encounter issues like transparency. Register generally use use edge-triggered clocking, where data is sampled only one clock edge. Clocking strategies are crucial in ensuring the proper functioning of synchronous system. Each strategy has its trade-off, and the choice depends on the system requirement for speed, power consumption, and complexity. Here you can see the setup time, hold time, clock to queue delay. Already we have discussed what is meant by setup time and what is hold time. Okay, yeah, let's just registers. Okay, for clock zero, which means which is transparent, the output is transparent one, and clock one means hold the previous output time. Setup time, hold time. Okay, clock, yeah, setup and hold time are key timing parameter for sequential elements such as flip-flop and latches in synchronous digital circuits. These parameters ensure that data is correctly captured on clock edges. If they are not met, timing violations can occur, potentially leading to incorrect data storage or system failures. Clock skew. Clock skew refers to the difference in the arrival times of a clock signal at a different point within a synchronous digital circuit. In large or complex systems, the clock signal does not reach all components at the exact same time due to factors such as varying wire length, capacitive loading, or differences in the delay introduced by the clock distribution elements. And some of the types of clock, already previous video we discussed positive clock skew and negative clock skew. Okay, if you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.